Hi, now we need to understand why recursion. We actually can do the same thing using a simple for loop, but why should you go for recursion? Is it beneficial to adapt a recursive approach in our program, or it is better to stick with the iterative technique using a for loop or while loop? So that's a critical discussion, and I'm going to give you some examples in this video and in the next couple of videos so that you can understand clearly when to adapt recursion and when to adapt iteration. So I've just modified the example of the previous tutorial a bit. Here I have just omitted the hello world printing message, and the rest of the things are just same. So it's going to print 3, 2, 1 in this case. That means I'm passing 3 here. So let me just change the name of the function as well so that it's become meaningful. I'm just changing it to say print number. Okay, and here it is print number, and the recursive call is also to print number. Okay, so now what it is going to do, it's going to print from n to 1. That means if I pass on 3 from main, then 3 will be received here, 3 will be printed, then oh, I need to decrement the value of n as well. That is a mistake. Okay, just let me decrement the value of n by 1, n minus minus, calling the print number function and passing n here to the print number. So in the next call it's going to be 2, and then it's 1, and eventually when n becomes 0, the return statement will be executed and the recursion terminates. Okay, now let me just show you what happens in the memory when this call goes on practically in runtime. So first of all, when this first call is going to happen, operating system obviously is going to create a stack, and main will be pushed in the stack. All the details of the main function will be pushed into the stack, and the first print number is called. So here the value of n is 3. Now n is not equals to 0. Okay, so that return statement doesn't take place. So here it comes and prints the value of n, and that is 3. That will be printed. Value of n is decremented by 1, 2, and again we are calling the same print number function with 2. So the next print number function is called from here, and I'm just writing n here without that unsigned integer just to make it simple. Okay, here the value of n is 2. This is the same function, but the instance is different. That means this is there in the memory, this is again created another instance, and this is also there in the memory. So when the call goes here, in the traditional function calling case, operating system would require to push the status of the current function into the stack. But here, as you can see, that it's the last statement from where we are just calling the function itself. That means the recursive call is made as the last statement of the function. On completion of the recursive call, when the control gets back here, we do not have anything left to do in the function. So in this case, operating system is not going to store anything into the stack because that's not required. Actually, on getting back, we don't have anything to do. So the operating system is not going to push anything, and compiler never generates the push instruction in such cases. Compiler is a clever one actually. It inspects the code and generates optimized code. So in this case, push operation for this function call doesn't take place, and again here the same code is executed. The same code is there. N is 2, so it's not equal to 0. The return is not executed. It will not be executed, and then printf will print 2. Here the printf goes ... Okay, so it prints 2, and then the value of n is decremented by 1, and it becomes 1, and then again we are calling the same print number, and we are passing n here. So the value of n that is passed here is 1. So again another print number will be called. That's the next one with n equals to 1, and here also the same code is there, and the value of n that is printed, going to be printed from here, is 1, and then the value of n is going to be decremented to 0, and now the final call to the print number is going to take place where we are passing 0 here. So in this case, when this particular print number is called, then n is received as 0. So now this is going to be executed. So the return statement is going to take place right now, executed right now, because n is 0. This is true, and the return statement takes place. Now the point is that where it's going to return. Is it going to return to the immediate previous print number? So the operating system is going to look into the stack for where it should return. So, and it finds main there because we do not have anything left in the callback path to do in these functions, because print number was the last call. So it looks into the stack and it gets main. So the main is deleted from the stack and the control gets back here. So in this kind of recursion, where the recursive call is made as the last statement, this is typically called tail recursion, and no stacking activity is there for the recursive call. So there is no overhead for the operating system. Had there anything left after this recursive call, then operating system would require to keep the status into the stack by pushing the current function information each time on recursive call, and that would create the overhead. That would definitely affect the performance. But here there is no stacking activity, as the recursive call is the last statement. So it's just equivalent with the for loop because it's doesn't have any overhead. So if you can write a tail recursion to do something instead of a for loop, then the for loop or any loop is just equivalent with the tail recursion. That means a tail recursion and a loop, they're just equivalent. So it's your choice. You can write a tail recursion or a loop. That's okay, no problem. You can go in either way. But there are situations when you won't be able to write tail recursion at all. The logic of the program or the need of your code may force you to write non-tail recursion, and that means you won't be able to implement the logic using tail recursion. In such cases, you need to think properly what to do, recursion or loop. I'll be discussing that in next video tutorial. So here you go, I'm just running this and showing you that it's printing 3, 2, 1, and you can see that it's 3, 2, 1. Done. Thank you.